All right, and we are live. It seems like we have two items on the agenda today. I guess I'll go ahead and get us started with the platform config part of the project descriptor. All right, that's not the screen or the get out of here. All right, there you go. So basically, this is a pre-draft RFC that I'm working on based on a lot of really good feedback and input from various parties on how we could essentially improve the build packs use case and usage of the platform, the project descriptor, right? So through a lot of conversations, I think we distilled it down to 3 goals. We want to be able to serialize the CLI configuration. So in cases like, let's say, pack, right, you want to have all these flags. I would kind of store the configuration that you would otherwise use as flags for pack to be able to configure pack, and then be able to check this into a repository and have everybody on your team, or anybody that checks out the repo, be able to build an OCA image using build packs in the same way if they were to use pack CLI.
Can I ask a question?
Yeah, of course.
Or do you want to go through? I think this was asked before in a previous working group, maybe by Sam or someone but how does this interact with like global configuration? Because you were mentioning this being checked in, right?
Mm-hmm.
So I assume this would be merged and maybe override global configuration. Are we planning on keeping global configuration?
When you're talking about global configuration, are we talking about the global configuration at the pack?
Yeah, the pack level, pack level.
This RFC doesn't go into that sort of detail. It kind of chucks it away as a sort of pack specific implementation, right? This is talking more or less about, we have this thing now, this additional file, right? And how do we merge essentially or utilize project descriptor with this other pack TOML file? I further down here, I do kind of punt the specifics of pack TOML off to its own RFC, which I think Joe is kind of leading on that one. So I think that's a really good question for that, if this all still makes sense, right? Does that answer your question?
Yeah, and so when you talk about CLI configuration, you do mean stuff beyond pack then, right?
Yes, like other platforms, essentially, right? You could think about KPack having its own configuration file, Tecton, Salesforce, I believe functions, that sort of stuff.
CLI configuration, is that just configuration or CLI configuration?
Fine, I'll change it, Sam. Platform specific configuration.
Okay.
These were literally copied and pasted from our previous notes, but yes, point taken. All right, any other questions on that first goal? So the second goal was making a file that is recognizable in these repositories, right? So kind of leaning a little bit more into, we're configuring pack through some sort of configuration file. I know from a branding standpoint, we want to have very similar kind of picture that Docker files have in repositories, right? You go to a repository, you see a Docker file, you know that it's using Docker, or you can use Docker to build that application. We want to do the same thing here, but for build packs. You go into a repository, you see a pack TOML, you know that you can use pack to build that application. Again, X number of platforms, you can kind of say the same thing. So we want to enable platforms to be able to promote themselves as a way to use their configuration file names, if that makes sense. All right. Yeah, please feel free to interrupt me as I go through this, but I know it's kind of lengthy, so I'll just kind of go through. The next one is, kind of tied into that to some extent is we have this project descriptor file called Project Toml. And one of the current challenges that I'm noticing is that some users kind of expect this file to be adhered to or recognized by all the various platforms, right? So when we're talking about, let's say, project descriptor, they want certain values from that project descriptor within the IO build packs namespace to be applied. And so they're surprised when, something on like KPack, it's ignoring environment variables or not being able to set build packs. And then you could kind of see that sort of trending in the alarm as you go into other platforms, and something that works on now my machine isn't necessarily reproducible on a platform or some other machine. That's kind of more or less the idea. And so that's the thing I care the most about. And this is just kind of tying and building on top of other people's work to kind of create this holistic view of something that we could achieve. All right, so with these three goals in mind, the things that I've heard and I've kind of distilled out of it is kind of proposing that we make three changes. So the three changes are moving IO build packs to IO build packs defaults. The prior art kind of being GitHub Actions, where the idea of defaults kind of really does mean defaults, and it's not the primary way to configure a platform, right? Primary ways to configure platforms should be pointed to those platform-specific configuration files and or namespaces. That's kind of more the idea there. I'll get into it in a little bit. The other one is supporting secondary files. And in this case, I'm naming them platform-specific configuration files. So I want to create something that applies and recognizes those as well, and not just project descriptor. Let's see. Last but not least, a replaceable new phase for the lifecycle called a prepare. And what the prepare does would basically merge and apply some of the platform configuration. And again, I'll kind of go into more detail. I'll try to go through this quickly. For the most part, the namespace defaults should declare default values that every platform should at minimum acknowledge, right? And I think this is a pretty big piece here, is that anything that we put into default, if it were to trickle down into the execution of the preparer, the user should be notified that certain properties are not being applied. And there's a strategy that I go into further on how that would be achieved. But in a general sense, this defaults area right now, as it stands, is just taking what we've currently got on project descriptor 02 and just bumping it up into the defaults namespace. Some of the things that I think this gives us is the namespace schema version, something that I think we're missing right now from project descriptor, or from, this namespace of the project descriptor. And then being able to have other keys within here as well. Last but not least, it is of my opinion that the name itself, defaults, kind of conveys a lot more, and it changes the mindset quite significantly to what it was prior, where your expectation is that this will just work on every platform. Now you're at least pointed to these are defaults, and there's got to be something else or somewhere else that kind of sets the concrete configuration for it. Some of the examples here that I have, I think I only have one, is this idea of where we could have multiple platforms, right? So we could have a pack and a KPack configuration all within a project descriptor. And this is the pack config area here and the KPack config area here. And then there's defaults that essentially would be applied to both platforms on that side. This is a pretty big chunk. I want to make sure I don't miss out on any questions.
I have a question on defaults.
Mhm.
Why, so you said you might go into it later in the prepare phase, but why not limit defaults to just things that can actually be implemented by every platform? So we
Because
discussed.
I don't.
Yeah, go
I was
ahead.
going to roughly answer that I don't know that we have a very concrete answer for that just yet.
I think one reason is that if you want to have a place, like let's just take Build Packs as an example. I want to set that once, and I want it to work on all the platforms I deploy to. But if we don't have a list of build packs in defaults because Kpack doesn't support that, then even though I'm not using Kpack, I would have to put that list in my pack section and my Salesforce section or Tecton section, right? So like by restricting what can go into the defaults based on what everyone can support, ends up in people using other platforms having to repeat themselves.
Yeah, that's a pretty good rebuttal as well, right? So that makes sense. Cool. All right. Now this is kind of, I guess, the meat of it all, of how this is unified, all the different components. So there's this preparer, and it comes from the idea, I think, that we had a converter at some point, an RFC for a converter. But I think we've wanted a preparer for a long time now. And I think this is a pretty good use case of a preparer, where the preparer's responsibilities are to merge the defaults with the platform specific configuration. It should have built-in kind of requirements to notify the user of any properties that go unused, whether it be on the defaults namespace or on the platform specific namespace. And then it should apply the configuration. And apply the configuration, I think that is still maybe a little bit nebulous, because it won't be able to apply everything, but it would most likely be able to apply a certain amount of it, right? I think we talked about environment variables. Like I can't think of a world in which, the out of the box CNB provided preparer couldn't apply the environment variables from a configuration file, right? That's just one example there. Let's see. The next thing, the next big hurdle, and I've been working on this today, is the merging, right? So let's maybe look at an example here where we have a let's see. Yeah, so we have this pack namespace in the project descriptor. We have a default here. So we've got defaults, and then we have this builder image that comes from the pack configuration specifically. If we were to, kind of let the preparer know that, hey, this is the namespace where you could find the the platform specific configuration, then the preparer itself could do the merging, and the end result would be the builder set to the pack-based configuration, and then also the environment variables would be, again, the pack-specific ones as opposed to the default provided ones. This lends a lot of the efforts and works from IETF, I've never had to say that out loud, RFC. And basically, there are a couple limitations that we have to work around, which is basically arrays are not appended, they're replaced, which I think simplifies the system. We don't have to worry about that, but I do foresee some users kind of wanting some append functionality. Open to discussion there. And then there's a limitation in TOML, which doesn't allow you to have, or doesn't have the idea of a null or nil, which is what the RFC up here uses to essentially unset or zero out, which I think is what Joe brought up at some point. A workaround for this is to do an empty table and use that as a way to unset things from the top. Let's see, that's for the most part it. You could see another example here where we have a project TOML, and then we have a pack TOML. I am kind of, I think, suggesting that we make a change to the current TOML, pack TOML RFC, in that I think we can go away from namespaces at that file level. And that's kind of how I'm going through this, but Joe, free to talk about it.
Yeah.
But the idea here is we have project TOML here, we have a pack TOML here. We let the preparer know that that's the namespace, and very similar effect happens in this regard. Okay. Sorry, go ahead.
I was gonna ask, we have to let the prepare know that that's the file, right? Or
Yeah.
not namespace. Okay.
Yeah, and I think that's a good segue into this. So this is the prepare executable. These are the configuration elements or properties to it. So we do have a config path, which would be the project TOML by default, a platform specific config path, the namespace, right? Because it does have to know, that information. And then there's another thing, an ignore property. And the ignore property is really useful for when the platform itself is taking care of that property. So like builder for pack would be a really good example, where before anything happens, pack is going to look at this file, whether it be the pack TOML or project descriptor, and it's going to determine what the builder is that it should use based on that configuration. And what it'll do is when it executes the prepare, it'll say, I've already taken care of the builder. You don't have to worry about that property. You could ignore it. And so by ignoring it, what that means is that it's not going to notify the user that it's not being used, right? So everything else that isn't in the ignore here, if the prepare doesn't know about it, doesn't know what to do with it, then basically it'll throw in a built-in notification or warning to the user. Let's see, other examples is the KPAC here. So this one will throw a warning. If, for instance, you had a builder set on it, or if you were to have build packs, right? If you have a set default group of build packs that you wanted to use, and you put this into KPAC, because KPAC is only taking care of include, excludes, and environment variables for build, this would actually warn for you. That's more or less the case.
Wait, I didn't quite get that. So those are ignored. So those would not be handled by the prepare phase.
Correct.
For things that are handled by the prepare phase, how, like, what is ignored? How does it know what's unused?
Because it would be based on the properties, right? So if it's not properties it is aware of, or it's not, or it's properties that are not in this ignored list, right? Then it would warn for all those properties.
So let's say there's a builder, and if the way to signify that the platform has already taken care of things and to signify that it doesn't support something are the same. Like you have to declare both of them through ignore. So let's say KPAC doesn't support builder, but it already takes care of include, exclude, and start build. How would it tell the prepare phase that even if you see the builder, ignore it, don't do anything with it? Because
so the prepare wouldn't do anything with builder already, right?
So let's say it's build packs instead. What is prepare, like what's the functionality that the prepare is able to handle?
The only thing I could think of at this point would be environment variables.
And include and exclude, right? Like it should also be able to handle include and exclude.
I think someone was arguing that that may or may not be possible.
How come?
Uh,
Because the platform API specifies that the platform has to mount the source code in a specific directory, right? Like the platform may have different ways to fetch it, but it has to have it present in the workspace directory at some point before everything happens.
Is the exclude, does the exclude happen before or after it's mounted?
After, I mean, before any of the lifecycle phases see it as they're currently defined.
Okay, so exclude doesn't mean don't export.
Right, it means that remove that piece of source code before detect or analyze or any of those phases run.
Yeah, so if it's able to do that, then yes, that should be doable as well. I guess maybe another, kind of thing we could dive into is that the preparer could change, right? So if KPAC wanted to introduce its own preparer that does know how to handle build packs, in a different method or mechanism, it could very much do so, right? But by default, out of the box, right now, if you were to execute this, right, you would get a warning that build packs, that you've declared build packs and that they're not being applied, that configuration is not being applied.
What does that warning logic look like? It just validates the builder or build packs in question are there, and if not, it warns? Or is it just,
Sorry, go ahead.
or is it just like checking functionality that the platform supports configured with it with what the descriptor has?
I was thinking more about it at a property level, right?
What does that mean? It just detects the presence of the property?
Yes. So only configuration level. It has no intimate knowledge into the properties themselves, how they're applied, and or the feature set of the platform itself.
So in this case, when you specify that platform config namespace, it is merging certain things from there, but it's also ignoring that entire namespace.
Sorry, could you elaborate on that?
So you said that the namespace can contain additional keys that are merged back into
Default.
defaults.
Mm-hmm.
So anything that the preparer is not aware exists in defaults will be left as left up to the platform. Is that what it means? So let's say KPAC defines property foo, which is not part of defaults.
Mm-hmm.
And what would happen when the prepare merges it? Like, will it just ignore that property entirely, merge the rest of the things it knows, and then ignore everything within that namespace?
Oh, that's a good one. I was definitely thinking more on the default side of things. If you were to have, some arbitrary default property, and then you apply a change and that property goes unused, right? And the platform doesn't have it as part of ignore, then it would say foo was, not applied. Configuration foo was not applied. The use case of, let's say, KPAC namespace having foo, we could do the same thing. I don't know if it makes sense.
Yeah, because okay, so the prepare only looks at two things, right? It looks at IO build pack's default namespace and the namespace you provide here to do the merging.
Yes.
But when it's doing the merging for the platform namespace, it only looks at the keys it's aware of from defaults, right? Like it can't merge things that it's not aware of. Otherwise, that's going to be a lot of things you had to ignore.
Right. I think that's the maybe the question. And I think we could, I guess the way I was envisioning this, and I don't know if I put it on here, is that it should be top level, right? So you could it's whatever you want to ignore and its children, essentially, right? So you could do that as some sort of that might minimize, so you don't have to do every individual field, right? You could just do properties. But yeah, that's something that I haven't considered.
Because like, for example, the CNB platform config ignore, the examples are not namespaced, right? They're just top level keys.
Yes.
So let's say I want my namespace to be VMware, KPAC, whatever, but I also want the prepare to ignore any keys that it's not aware of there. How would I specify that?
So first off, it's not defined right now that that functionality you propose would be something that comes out of the box. So that is pretty much an open question, right? Like, would it even look at other platform config namespace properties, or would it just ignore those by default?
Okay.
Right.
And yeah.
Let me write that down. I mean, do you have a preference?
I mean, I would prefer if it just ignores everything it does not know by default, but it gets into a murky place, because let's say this COM VMware KPAC that has its own schema version. IO build packs will have its own schema version. When it's trying to merge those two things, and let's say at some point the IO build pack schema version was something new that the VMware KPAC schema version is not aware of. So let's say we moved build packs from like IO build packs dot group to IO build pack dot groups, you add an S or something there. And now KPAC is still using the old like schema as a platform to specify the build pack groups. How will it do the merge? Because the COM VMware KPAC will have its own schema version where it says these are the keys that I am aware of. All of them must be compatible with the IO build pack schema version, right? If it has to override them.
Yeah. I mean, I think the more I think about it from a platform's perspective, the more I actually don't want them to ignore it by default.
But then how do you solve the schema discrepancy while merging things?
So it's not while merging, right?
It might be because of, so let's say I define that the COM VMware KPAC table version 0.1 has build packs, let's say, or groups or group, whatever. And that maps to IO build packs dot group or groups.
Right,
and at some point we rename that, bumped up the IO build pack schema version, but
you're saying, yeah.
So like what happens in that case? Because there's nothing that the preparer would know. Like how do you handle schema bumps between prepared?
That's the big empty section right there. I haven't gotten to that point yet. I didn't want to go do too much work up front if this is all something we want to throw out. But yeah, that is a really good kind of thought experiment.
Because the more I think about merging, the more I like that would be a compact layer in itself. Like it will have to know about the platform schema version. It'll have to know about the build pack schema version. It'll have to know how to merge and resolve those.
Yeah, and I think this is where, I mean, it's the tail end of this, right? But CNB maintained utilities, whether they be Go library functions or just the executable that's shipped with the lifecycle. I think those are one of the things that I think are necessary in order for there to be success in this sort of strategy. And I think that's maybe a place where we could provide that sort of functionality, right? Is where platforms have this kind of pre-built notion on how to do the merging, right? Because we don't want to have every platform have to rebuild that. And then also this upgrade strategy, whatever it may be that we come up with.
Might simplify things if, like, at some point you said prepare was pluggable, right? Like you could change the prepare version. So like if whatever the platform is owns its own prepare phase or owns a prepare phase that's compatible with X platforms, if that can specify the project descriptor version it's compatible with and the platform schema versions it's compatible with, then it can handle upgrades. So let's say I have prepare phase from, I have a prepare phase that works with KPAC version 0.5 and PAC version 0.23 up until that version. And it knows how to handle, or rather than the PAC or KPAC version, it knows how to handle certain schema versions under the PAC TOML or COM-VMware KPAC table. And it knows how to handle certain versions of the IO build packs schema. And if it doesn't find that, it just fails, says this file is out of my reach. I don't know how to handle it. And then that can, that will need to have some custom merging strategy to map different schema versions across these two tables.
So, but I'm thinking about it from a user's perspective, right? Like the platform TOML and the, let's say, PAC TOML or KPAC TOML in this merge process or before the merge process, both of those things are part of the same repository and coexist, right?
Yep.
So it's not like a separate entity owns one piece and then another entity owns another piece, right? So the user could just simply upgrade both of them. Wouldn't that be the solution there?
Yeah, assuming KPAC at that point released the new schema version that corresponds to the new build packs default schema version. So let's say the new build packs version introduced some new features you want to take advantage of. You still want certain overrides from the KPAC side, or like which are not by default present in IO build packs. The more I think about it, the more like it's weird to duplicate like keys across files, at least. If it's dynamic configuration you're passing through CLI or through like the spec, it makes sense. But if it's in the same repository, why would you have one configuration in your project TOML and another one in your PAC TOML? Like if the goal is cross-platform compatibility, why would you split that across two tables and make certain settings specific to PAC and override the defaults in IO build packs defaults with that? Like you may want to set certain flags that are specific to PAC which are not available in IO build packs default, but why would you want to merge them in the same repository? I'm not talking about runtime. Like,
yeah, no, I think it's possible that you have the defaults. Let's say your default is some Java build pack, and then when you're running, that's for your production environment. And then when you're running PAC locally, you want the Java build pack and some debug build pack that helps you like hot load changes or something like that. So I think in some ways it may be unique to PAC because of the local use, but I think that's one reason you might do it that way.
But why wouldn't you pass that as CLI flags? Why would you check it into the repository?
Oh no, I think there's a really good case for that. I mean, I don't want to have to pass flags in all the time. I mean, I guess like the alternative is a makefile or something, but it's nice. I think for just about any option, I want to be able to serialize it. So
The
that
concept-
is the use case, I think.
Yeah, the concept of these like platform specific environment variables seems to make sense just because like variations of platform, perhaps you like want a more complete build or something, different environments. But I'm wondering if like we'll actually get that much value by formalizing this merging logic. It seems like at the end of the day, it's largely going to be around purely environment variables, which seems like an easy thing for each platform to solve individually. KPAC probably would maybe resist a KPAC specific environment variable because that would create 3 locations that KPAC users are providing KPAC credentials. So we probably would be maybe reluctant to do it. And it seems like PAC on its own is likely already going to ignore this to read it before the build starts. So I guess I'm just wondering to what extent the merging functionality is actually solving a problem a platform has.
So could you elaborate on why PAC would want to ignore it? Because at some point, I mean, it'd be nicer if the platform just took care of it. Or sorry, yeah, the lifecycle prepare just took care of it.
I guess I was assuming that for speed benefits, PAC would pre-process this to avoid needing to prepare to do work. Things like include, exclude, PAC can do faster than if the prepare is doing it. And it felt like at that point, probably env might be simplified if it was also due externally, but maybe it makes sense to do it inside. But even then, it's just, isn't this merging functionality then almost exclusively for PAC?
I think the merging functionality is, well, I mean, the 2 files is at this point exclusive to PAC, right? But the merging of, a defaults versus different configurations is not exclusive to PAC.
I feel like what the case that Joe was describing is more like the case with customized overlays, where like you have different environments and you can overlay it on top of one another to create the final actual file. But let's say you're using PAC also for your CI, and then you put those debug build packs in your PAC toml. Wouldn't that mean that you're now introducing those debug build packs in your CI?
That's true. That's true. Which might, yeah, which I think speaks to why you might want to have more than one file. Like, and I mean, right today, PAC accepts like a -p option, I think, for build, where you can name your project toml whatever you want. Or maybe it's -c, but you could have like a pack-dev.toml or something like that, and just pass it explicitly.
We
or
support that.
PAC
We
CI.
can you can pass like the explicit path to the project descriptor. So like if you want a dev project descriptor.
Yeah.
So
I'm saying that I mean, yeah, I mean, you're right. That is an interesting where it doesn't make, it makes the thing I was describing not so clean cut. Yeah.
Because the other option I can see is like having a PAC flag, for example, that like a local flag that sets the default project descriptor file name. So while you're doing things locally, you can do like default project descriptor config file name is dev.project.toml, and you'll see.
I mean, that could go in .pack/config in the home directory, right? Yeah.
Or so. I mean, I also don't want to conflate like different environments, but same platform with different platforms.
So you're saying that same thing could be used for the case where I was describing, where you want different build. I think you may be right. I guess what would make that, you could also have like that same .pack config, the way that Git would have it, where you have like a global and a local, and you just Git ignore it, so that you could have. That might get a little hairy, like when people start cloning.
Yeah.
But
like
I don't know.
I like relying on git ignore to ignore an important configuration file like
Mhm.
seems a bit weird to me. Like if it was auto-generated
Well,
or something, but
yeah.
So there's multiple pieces here, right? So there's the idea of needing multiple files, and then there's the idea of merging namespaces. And I think those are two very, like mutually exclusive things that we could talk about. But I think the part where the different namespaces exist and the reason why we want to merge them is to enable, platform specific configuration. When we talk about keys that might not make sense at this like global, top level section.
that still doesn't explain the merging though, right? Like if there's platform specific configuration, I'll put it in my platform namespace. Anything that Buildpack supports by default, I'll just override that value in the IO Buildpacks defaults section. Like
Not
why
sure.
would I?
So is this something you're saying like would exist without this change? Without any of these changes in today's world?
The only use case I see this solving is merging Pack Toml with Project Toml. That seems like a very Pack specific use case. I don't see any other platform needing this. And the reason why we want a Pack Toml is for the recognition, right? Like we want a more easily recognizable file for build packs.
So the part where I'm trying to solve is like the io.buildpacks, namespace before the defaults, right? As it stands today, is we throw stuff in there, and not every platform is required to acknowledge that configuration exists. That's the part that I'm trying to solve, and I think this is leaning towards.
But how would this solve that? Like if you put a builder in there and Kpack doesn't support it, how like it's just logging a warning, right?
Yes. Mm-hmm. Something that is not there right now. So you go to Tecton, right? If we don't build it, it doesn't come, right? And now you're having to do this for every single property that could, as the project descriptor grows or as this namespace grows, you're having to go back into Tecton, go back into Pack, go back into Kpack and saying, I don't support this. I don't support that. I haven't implemented this yet.
I've got to drop in 2 minutes, but just want to say a few things. One, first of all, thank you for writing this up. I really appreciate iterating on this and putting it together so we can talk about it. Second thing is, I would probably approve this as is. I think there's things we should figure out, but I think it's aligned enough with my thinking that I would go with it. I think the gaps that we have are worth figuring out. One change I would require is actually for the pack toml. I think you should have a top level pack table, but that's not a big deal. And then the last thing is I would like to think about doing away with the defaults table somehow. And I wonder if the existence of io.buildpacks.pack is the thing that's requiring the defaults table. Like what if we moved pack out from the IO build packs table altogether? But I'll spend some cycles thinking about that. But even with the defaults, I don't like that, but I might even compromise on it. So yeah, that's my thinking.
Cool. All right. I know we had another item in our agenda that I think we might have overlooked. Are there any other thoughts? Do we think 10 minutes is enough for the next item? I don't know who put that on there.
I put it on there. That was just something I wanted to share. Don't know if other people might find it useful. But Kivono is a sibling CNCF project. It's a policy engine that can enforce or like allow you to create mutation or validation webhooks using YAML files. So like one of the use cases that I generally come across is like restricting images based on the build packs that we used to build them, or like the base images that they have, or the default user on the container image, or like things like that. So the proposal is to like add a bunch of such functionality first class to that webhook, so that you can say that if this image doesn't contain build pack for version 1.0, then reject it. So, or something like that, or like I know that I let's say there's a, just giving an example because that's the one I know, like there's a Paketo Go dist build pack where we updated the Go version from 1.15 to 1.16. And we know that 1.15 has a bunch of vulnerabilities, and we want the minimal Go dist version to be like 1. Whatever. So you can enforce policies like that or other things. It's just something I wanted to throw out there while we think about moving things out of the label, like what kind of information we might want to put in the manifest. So like the current design supports reading manifest annotations, config blobs, and things like that. But like, I don't know if that's a requirement you've seen on your side, but that's like something I care a lot about, like validating the image outputs and making sure that there's no misconfiguration or invalid builders or build packs or base images being used, or if the base image is too old with no patches. So yeah, they also, like, I attended their community meeting. They were interested in knowing about build packs and like what other integrations they can have with us. So that's also something.
Where does the policy thing kind of fit in? Like, is that like done at the platform level? Is that done in lifecycle?
Oh no, this, I mean, it's not at all like, it's the policy, all of that stuff is implemented by their controller. It's just that it reads the metadata we put out to do the policy enforcement. Like lifecycle puts out the list of build packs and their versions. So I just wanted to point out that the current implementation that is proposed relies on being able to read the manifest and the config blob. Like reading layers would be potentially too expensive to do in a validation webhook setting. So I just also wanted to point out, like, these are some of the things we might have to think about when we move things out of labels into either layers or manifest annotations.
So if I'm not mistaken, or maybe, I don't know if you answered it, but layers would probably be the more difficult
Yep.
to use across different projects. Yeah.
Manifest annotations for like small metadata would be great. Like whatever metadata we're currently storing as labels, it would be nice to move them as manifest annotations. Moving them to layers would probably make sense for things like SBOM, which are like fairly large.
So from a technical side of things, I know the labels cause a lot of issues for image loading and stuff like that. Do annotations not have the same restriction at all? Like, are they just discarded?
It's not even discarded. It's just that the manifest is a registry only concept. The config is a runtime concept. So manifest is like something that describes how it's stored and metadata about that, whereas the config is actually used by the container runtime to like spin up the container, so it's aware of it and retains that information. The original use of labels, I believe, was Docker introduced it to filter through containers with certain label values. So like you could filter containers that are running with label app equals like environment equals production or something like that. But it's been misused, and like the way labels are right now, like it's nowhere even close to what they were meant to do.
I mean, doesn't AWS also have the idea of labels, and then they started using it for things like user data? So like you put scripts and labels or something like that?
Not, I don't know what you're talking about.
Oh, sorry.
But it's sort of it's sort of similar to Kate's annotations and labels. Labels are indexed and things you can filter on. Annotations are large pieces of data that you can just store there to know that, hey, this property was set to this value.
All right, anything else? Circling back a little bit to the project descriptor stuff. If you haven't, or if you need more time to think about it, please review the document, and feel free to reach out and have, one-on-one conversations about things that might be concerning or otherwise.
How much, I noticed the upgrade section's empty, and that's kind of where we stopped our discussion. How much thought have you collected for that, and you just haven't written it down yet? Or
I have not collected any thoughts on that. I feel like as typical, it's pretty hard, right? And it'll require some sort of give. Somebody has to give a little bit. So
yep.
One of the things I was hoping for with this proposal was a closer tie to the platform API, so that we could actually, like, our goal of consistency across platforms is easily enforceable if we actually introduce it as a part of the platform API.
So that is true. The thing that I think is still not associated is the idea of a schema version to a platform API, right? I think the converter tried to do something like that, but in this current proposal, that's definitely not a goal, and it doesn't seem like it's a fit in my mind.
So does that mean, what does that mean for the converter RFC? If we went down this path and merged this in or baked it into this?
So I think the challenges with the converter were that it made changes that then the platform had to read after the fact, and it discarded everything that was platform specific. So it did a partial job for certain things, and I think
that's what the prepare stuff is meant to kind of tackle anyways.
Yeah, I mean, ultimately, I think it shifts away from there being this like central configuration to just there being a platform specific configuration, right? And it's really the platform's responsibility to take ownership of that. And there's a little bit of leakage there in the prepare, but that's only so that we could handle 99% of the cases for pack or like standard cases, but platforms could replace the preparer so that it does stuff that they want with only their configuration, and totally irrelevant or discard all the build pack related quote unquote defaults. All right, well, with that said, I think I'll